Hey class! Yesterday I gave you guys this worksheet to work on, and it was a completion worksheet. And since I'm not going to be in class today, I promised to post the answer key. And while if you get the correct answer, the answer key is awesome, I'm going to kind of put this video up and walk through the problems in case you weren't for sure where some of the numbers came from. So first, we've given you 2 problems and each one has 4 parts. This combines Friday's video and yesterday's video together. Step number 1, we should have balanced the chemical equation. And if you haven't balanced it yet, it comes out to be 3 zinc, 2 MoO3s yields 1 MO2O3 plus 2 zinc oxide. Now, part A says, what is the mass of ZNO that is formed when 20 grams of MoO3 is reacted with 10 grams of zinc? So note that these 2 things are my reactants, and those are the 2 grams that I'm given, and you're going to have to do 2 different conversions. The first, you're going to have to start with 20 grams of MoO3, and the second conversion, you're going to have to start with 10 grams of zinc. Both of these are going to be going to mass of ZNO because that's what it's asking for. ZNO, if you notice over here, is one of my products. So if I start with the first one, 20 grams, your key person is whatever you're given, get it into moles first. So in order to go from grams to moles, we want to use molar mass. To cancel out grams, we need to put grams on the bottom. So I'm going to find molar mass of the MoO3. This is where my first number comes from. 143.937 grams of your MoO3. Now, whenever you're working with molar mass, it's always going to be 1 mole because molar mass is grams per mole. And this is also going to be MoO3 because these have to be the same. Once you get it into moles, you can switch it to the other compound by using mole ratio. So here I want to get to ZNO. To cancel out this moles, though, it has to go opposite. So moles of MoO3, and then I want to get to moles of my wanted, which was ZNO. In order to get the numbers out front, we have to look at that balanced chemical equation. This is really the only time you really need that balanced chemical equation for your mole ratio. So here I'm going to find MoO3 and see that it is 2. Here, this one's not balanced correctly. This should be a 3. I'm going to look at this one. For ZNO, this is a 3. And then that helps me cancel out moles of my MoO3. I'm in my moles of ZNO, but I have to get to grams of ZNO. Well, then in order to get from moles to grams, we use molar mass. So to cancel it, notice I have to put my moles opposite. Moles of ZNO and grams of ZNO. The number that I'm going to put up here, 81.389, is going to be the grams of my zinc oxide, the molar mass I found for this one. So you add those atomic masses together. Here, if you're working with grams and moles, it's always over 1. And when you solve that out, you get 16.96346318. But since we're rounding to sig figs, it's going to be 17.0 grams of ZNO. Then make sure everything cancels. My grams of my MoO3 cancel, my moles cancel, these moles cancel, and that leaves me with grams of ZNO, which is what I wanted. Down below, we're going to do the same conversion, but with the other reactant. We're still going to go to ZNO. So here, it's going to be the same steps. I need to find my molar mass, but notice that this number is different because this is the molar mass of zinc. It's still going to be 1 mole, though. Then we're going to use our mole ratio. So here, we know that 3 moles of ZNO, but notice if we're going to cancel moles of zinc, it's got to be on the bottom. And we're going to look up here and notice that's 3 moles. From there, the last part of the equation should be the same because we're still going to ZNO. So this one's still going to be 81.389, and this one's still going to be 1 mole. This gives us the problem 12.4467039. But if we're rounding to correct number of sig figs, we need 3 because we're starting with a 10.0, so 12.4 grams of ZNO. So here I have two numbers for mass of ZNO, but how much is actually going to be formed? Remember, the one that's actually going to be formed is the lowest amount, which is why on the answer key, this one was boxed in because this is actually the correct answer. That allows us to determine the second part. Oops. Who is my limiting versus who is my excess? So limiting is going to be the one that was the smallest product is going to be the limiting reactant. So that was zinc. The one in excess will be the larger one. So here's my larger answer. So MOO3 was my reactant that yielded that. That means zinc, the amount we have for zinc, is going to limit everything that can happen in this reaction. So even though I started with 20 grams of MOO3, I'm not going to use that all. So we need to next figure out, for my reactant in excess, how many grams did it actually use? So in order to do this, we know limiting reactants limit everything. So we're going to start with this one, ZN, and it has to come from the problem. If you look up in the problem, we started with 10 grams of ZN. A lot of people want to use this number over here, but this is our product. We want to start with our limiting reactant, which was here. And we want to go to our reactant in excess. So when we do this, we're going to be setting up multiple conversions. So here's my grams of ZN. If you want to look up above, you have this already laid out. 1 mole of ZN is 65.39 grams of ZN. Note, this allows us to cancel grams of ZN. And next, we have to go from moles of one compound to moles of another, and the only way we do that is a mole ratio. So up above, we can see that we had 3 moles of ZN, but then I need to look at my reactant in excess, which was MOO3. And for moles of MOO3, we had 2. Again, you just have to check that with your balanced formula above. Notice MOO3 is a 2 and zinc was a 3. That's where we got those numbers. Then we want to go to, we've canceled out moles. We have moles of MOO3. We want to go to grams though. So for every 1 mole of MOO3, we need to find the molar mass of it. And we've done that already up above. If we look up above, we found the molar mass of MOO3. It was 143.937 grams of MOO3. This allows us to cancel out these moles and to find out our mass of our MOO3 that was actually used. When you guys go to solve this, you get 14.6747291. To round to correct number sig figs, because this is technically 10.0, this needs to round to 3 as well, 14.7 grams. Make sure you label it MOO3, and this was how much was used. The last thing to do on part number 4 is for the reactant in excess, which was my MOO3, how many grams were actually left over? So we need to figure out how much did I start with and how much did I use? Well, if we look up in our problem for MOO3, we started with 20 grams. So for MOO3, we started with 20.0. Subtracted, we used 14.7, and this gave us a difference of 5.3 grams of what? MOO3, and this was how much was left over. Notice this is 1 after the decimal, 1 after the decimal, so my answer should have 1 after the decimal as well, since I am subtracting with sig figs. If you're still confused on any part of that, please make sure that you email me, and let's go ahead and work on the second one. So here, if you have not already balanced the chemical equation, it should have been a 1, 5, 5, 1 to be a balanced equation. This one was a little bit harder to balance, but you should have been able to work it out with a little bit of trial and error. If you're still struggling with balancing chemical equations, just come up to me and we can give you some more practice. Okay. Part A is going to work a lot like Part A up above. It says, what is the mass of I2, which is one of our products here, that is formed if we start with 80 grams of diiodine, and this is actually correct on your paper, pentoxide, reacts with 58 grams of carbon monoxide. So there's my two reactants. So we're going to start with both of those. It said I started with 80 grams of I2O5, and then it also says I'm starting out with 58 grams of CO. Both of these need to go to the mass of I2. So I need to get to grams of I2 for both of these. Just like up above, we're going to follow the same series of steps. We're going to go grams to moles, moles to moles, and then moles to grams. So again, we follow the simple steps of grams to moles, to grams. So in order to go from grams to moles, the first thing we have to do is molar mass. Notice molar mass is always 1 mole. And then I'm finding the molar mass of my compound that I'm starting with. So the molar mass of I2O5 is 333.795 grams of I2O5. So 2 times iodine's number plus 5 times oxygen's number. Then this allows us to cancel out the grams. We need to get rid of moles. So to go from moles to moles, we're going to use our mole ratio. It's called a mole ratio because a ratio is a division of moles over moles. Here, to cancel out moles of I2O5, we're going to put that on the bottom. And then we're trying to get to moles of I2 because that's the compound we want. These numbers, though, come from our balanced chemical equation. Again, this is the only time we really use coefficients. So this is a 1-to-1 coefficient. That allows us to cancel moles of I2O5. Now I need to get to moles to grams. Again, we do that through molar mass. So 1 mole of I2 is equal to what mass? Well, if you take iodine's number times 2, you get 253.8 grams of I2. Then you can go ahead and solve this out and get 60.82775,356. And when you actually round this to correct sig figs, it's 60.8 grams of I2. Down below, we're going to follow the same steps. Grams to moles, moles to moles, moles to grams. So first, molar mass. So 1 mole for molar mass always. And then this one's 28.01 grams of CO. This 28.01 is carbon's number, 12.011, plus oxygen's number, 15.999. Then I can go from moles to moles using mole ratio. So to cancel it, it's got to go diagonal. Moles of CO, and I'm trying to get 2 moles of I2. Note, again, this is the only time we use our coefficients. So moles of CO, that's here. I2, that's 1. Note, again, coefficients are only used for the mole ratio. If you're doing molar mass, it's always 1. Okay. That allows us to cancel moles of CO, and then we can go to mass of I2 using the same conversion we did up above. When you guys go and equal this out, you get 105.1081757. And for sig figs, this is 105 grams of I2. Which one is the actual correct mass of I2 that can be made? It's going to be the lowest. So this is how much iodine can be made when we have 80 grams of diiodine pentoxide and 58 grams of carbon monoxide. So looking below, this is the number in the lowest amount, which means I2O5 is my limiting, and then this one is going to have to be my reactant in excess. So again, limiting should be I2O5. Reactant in excess is your carbon monoxide. Now that we know that diiodine pentoxide is going to limit everything, we need to figure out, well, even though I'm starting out with 58 grams of carbon monoxide, how much did we actually use? So you always start with your limiting because that's what's going to change everything. So if I look at my I2O5, I started with 80 grams of that. So down below, we're going to start with 80 grams. And we're going to do the same conversion. We're going to go from grams to moles using molar mass. So every 1 mole, there are note this number is the molar mass of that compound. Then we can do mole ratio. So if you look at the balanced chemical equation, there's a 1 in front of I2O5, and there's 5 moles in front of the CO. Again, we got that from up above, 5 moles in front of the CO and 1 in front of the I2O5. That allows us to cancel out moles of I2O5, and then I got to go to grams. Notes, my molar mass of carbon monoxide is 28.01 grams, and grams is always attached to 1 mole. Even if the balanced equation says there's 5 moles of CO, when we're working with grams and moles in a molar mass situation, it's always grams per 1 mole. You guys can solve this and get 33.56551177. Correct number of sig figs. Since I started with 3, it should end with 3 as well. Don't forget to label. So here I'm working with CO. If you don't put the correct label, are you working with I2O5? Are you working with iodine? Make sure you let me know. And this is how much carbon monoxide was used. For the last step, we want to find out how much was left over. Again, you need to know what you started with and how much was used. So if I look at carbon monoxide in the beginning with, oops, that's my cats. We started with 58 grams of carbon monoxide. So here I have 58 grams of carbon monoxide. Oh, and let's actually rewrite that as 58.0, so I keep track of my sig figs. Minus 33.6 grams of CO was actually used, and this gives me a difference of 24.4 grams of CO that was left over after my reaction. Notice 1 after the decimal, 1 after the decimal. My answer has 1 after the decimal. And that is because we are subtracting there. And that's the end of me kind of walking over through some of these steps. If you're still confused, I highly suggest you come in before or after school, rewatch the lesson video, rewatch this, or shoot me an email. And otherwise that, I hope you guys have a great day.